Yes, let us now discuss Ampere Maxwell Law, or also called as the modified Ampere Law. Ampere Law we obtained earlier as curl of B bar is equal to mu J bar. We also saw the equation of continuity, that is when we apply for the AC circuits, we get divergence of J bar is equal to minus dou rho by dou T, where rho is the charge density. Now, according to this equation of continuity, we have to make some correction in the Ampere's law, that is curl of B bar is equal to mu J bar, because we saw that the divergence of J bar is not equal to 0, but Ampere's law, according to that, the divergence of J bar would be equal to 0. Now let us rewrite this equation of continuity using the Gauss law of electricity. In Gauss law of electricity, we know that the divergence of D bar is equal to the charge density rho. So here we can therefore substitute the charge density rho by this equation. So therefore equation of continuity can be written as divergence of J bar is equal to minus dou by dou T of divergence of the electric flux density vector D bar. Or we can write this as the derivative can be taken inside, that is the derivative of the divergence is equal to the divergence of the derivative. So therefore we can write it as minus del by del dot dou D bar by dou T. Or I can take this right hand side to left hand side, therefore I can write del dot J bar plus dou D bar by dou T is equal to 0. That means it is not divergence of J bar equal to 0, but divergence of J bar plus dou D bar by dou T, that is equal to 0. So this is the correction we have to make in the Ampere's law. So therefore Maxwell suggested this correction to be made in the Ampere's law, that is in place of J bar we have to substitute by J bar plus dou D bar by dou T. Therefore the Ampere's law now becomes curl of B bar is equal to mu times J bar plus dou D bar by dou T. So this is called as the modified Ampere law, or also called as the Ampere Maxwell law. Now we have got the four equations. One is the Gauss law of electricity, second one is the Gauss law of magnetism, then the Faraday's law of electromagnetic induction, and now the Ampere Maxwell law, or the modified Ampere law. So these four equations are known as the Maxwell's equations when they are written in the point form like this. So we can summarize again. The Gauss law of electricity, we got divergence of the electric flux density vector D bar is equal to rho, the charge density. Gauss law for magnetism is divergence of magnetic flux density vector B bar is equal to 0. And Faraday's law of electromagnetic induction is the curl of the electric field vector is equal to minus dou B bar by dou T, where B bar is the magnetic flux density vector. Now we got the Ampere Maxwell law, and that is the curl of B bar is equal to mu times J bar plus dou D bar by dou T, where D bar is the electric flux density vector, J bar is the current density vector, and D bar is the magnetic field vector.